Okay, we are ready to cover Unit 11. We're going to learn some really cool stuff about exponents. So the I can statement for 11.1 is I can multiply and simplify monomials. So we're going to write the word monomials. Monomials right here using something called the product rule for exponents. So the product rule for exponents. So go ahead and write those down there. So we've got monomials right here and then product rule right there. So the warm-up here, let's take a look at this. It says there are two parts to an exponential expression like b to the x. What is the b called and what is the x called? Well, we use this letter b for a reason. This is called the base. All right, so that's the base. And then the x there is the exponent. Exponent. All right, so we've got the base, big number right here, and then the exponent is written smaller, and we call that superscript. It's written up above there. Exponents are short ways to write an addition, subtraction, division, or multiplication or division problem. We just want to circle one. Remember, exponents are a short way to write repeated multiplications. So I'm just going to write repeated multiplication. We're going to use that idea several times. So repeated multiplication. All right. And then here it says, what does 2 to the third mean in expanded form and what number does it represent? So if we say 2 to the third, 2 is the base, 3 is the exponent. So the 3 tells us how many times we use 2 as a factor in a multiplication problem, how many times we repeat it. So this is going to be 2 times 2 times 2. And we can come up with the number for that. The number that would equal would be 8. All right, so this is called expanded form. This 2 times 2 times 2, all three of those multiplied together, and then this right here, that's the number that it equals. Okay, so if we take a look at the next one, this is problem D. It says, what does x to the fourth mean in expanded form? So again, the exponent tells you how many times you use the base in repeated multiplication. So this is going to be x times x times x times x. So that is expanded form. That is literally what x to the fourth means. And then it says, can you write down what number it represents, why or why not? The answer to that is no, and the reason is we don't know what x is. We're basically saying, look, I know I'm supposed to multiply x by itself 4 times, but I don't know what number it is. When you tell me what number it is, then I could figure that out. Okay, and then the next part it says, in the expression negative 6y to the fifth, what is the coefficient, what's the base, and what's the exponent? So the coefficient, remember, a coefficient is the number that's sitting out in front of that term. So it's the number that we multiply by out in front. So negative 6 is the coefficient. The base on this one, and this is important, we'll mention this several times, the base is whatever the exponent is over, and it's only over one thing unless we put it in parentheses. So the base on this is just the y. So the base is y, and then the exponent is, of course, the 5 right there. And then it says, what does negative 6y to the fifth mean in expanded form? So we've got 1 negative 6. Okay, the negative 6 is not in parentheses. The 5 for the exponent only applies to the y. So we have 1 negative 6. There's no repeated multiplication with that negative 6. And then we're repeatedly multiplying the y by itself 5 times. So there's a y, a y, a y, and a y. All right, so that's what it means. So that's all there is to that one. And then it says, please recall that terms in algebraic expressions are separated by plus and minus signs. Plus and minus signs. In other words, they're the operations of adding and subtracting. So if we ever see addition or subtraction in a polynomial or something like that, that's what breaks it up into terms. And remember, terms are made up of factors that can be numbers or variables. We've got one here that's got a number, coefficient out front, and then a variable, in that case y. And it says numbers in front of the variables are called, let's remind ourselves of this, the word is coefficient. Got to make sure that we have the vocabulary down, coefficient here, and then plain old numbers are called constants. All right, now if we take a look at example 1 here, it says, how many terms do the following expressions have? Name the coefficients of each term. So how many terms does this have? So we look through here and we'll notice this is 3x minus 2y plus 4. So we have 3 terms. Okay, now this guy right here, it's a plain old number. That is a constant. So I'm just going to write constant right here. And then it says name the coefficients of each term. This is not a coefficient. It doesn't have a variable in it, so that's just a constant. That's why we named that. And then these two, the 3 and the negative 2, those are the coefficients. So I'm just going to write coef like that, and we'll call that good. Okay, so 3 is the coefficient for this, negative 2 is the coefficient for the y, y term. And again, the sign that's in front of there, we drag that along with the coefficient. So the coefficient here is a -2. The coefficient here is a +3 if we were to, kind of state that out loud. Let's take a look at this one right here. There's a term right here, -5x² plus 2y to the third. So we'd say there are two terms right here. And let's identify the coefficients here. -5 and 2 are the coefficients. Okay, so we've got the two coefficients right there, and no constant on this one because there's not a plain old number there. And then if we look at this one, we've got three terms on this if we were to look, but notice this has an x² right here and an x² right there. That means those are like terms and they could be combined. So I'm going to write down three terms unsimplified, and then if we were to combine those, so I'm going to put the two of those together, that's going to be 1x² plus 8x². That's going to be 9x² minus 4y³. So we have two terms if it's simplified, two terms when it's simplified. All right, and the coefficients would be 9 and -4 are the coefficients there. Okay, again, vocabulary is really important. We've got to know what we're talking about, especially when other people use those terms and throw those around. We don't want to get confused by those. Now, algebraic expressions that have one term are called, get this, they are called monomials. So the prefix there is monomial. Okay, monomial. The word mono means one. Okay, if they have two terms, then they're called binomials. Okay, and you might be able to guess, mono means one, bi means two, so if they have three terms, then they are called trinomials. Now, we're not going to deal with a bunch of binomials and trinomials this year, but you will deal with those in the coming years. We're going to deal with monomials for the time being. So today, everything we're going to do is dealing with monomials, and we're going to do one specific thing with these. We are going to multiply them. So multiply them, and we're going to take the answers and we're going to write them in simplest form. Simplest form. So we're going to make sure that our answers are written as simply as possible. So this one says multiply the monomials and simplify the results. So let's take a look at this. We've got 2 to the third times 2 to the fourth. So we've got some repeated multiplication here and some repeated multiplication here. So I'm going to write these in expanded form. This is going to be 2 times 2 times 2 times, got to have another 4 2's here. So there's our 2 to the third, and there's our 2 to the fourth. Now, if you look at this, you might think, well, wait a minute. We're just repeatedly multiplying by 2 a whole bunch of times. Let's figure out how many times. So we're going to write down 2, and let's see. There's 3 here and another 4 there, so that would be 2 to the 7th. So I'm going to go ahead and circle that. We could write 128 if we wanted to, but for most of these, we're just going to go ahead and leave these in just exponential form. So we're going to leave them with the exponent there. So if we take a look at this next one, x², that's x times x, we've got two x's. x³, that's x times x times x. So there are x², there's our x³. We've got two x's here, three x's here. Again, we've got repeated multiplication. So the easiest way to write this would just be x to the fifth. Now let's take a look at the next one. Keep in mind that if there's no exponent written, that's an exponent of 1. We've only got the 1. Okay, so we've got a y here, and then we've got 9 y's for this next one. So I'm going to make sure that I get all these in here. Let's see, there's 1, and there's 3, 6, 9. Okay, so I've got them all written down there. And again, this is repeated multiplication with just a y as a factor. So let's write this as an exponential. Let's use a base of y, and then let's count how many there are. If you count them up, there are 10. So this would be y to the 10th. Now, I'm hoping that you've noticed something about the numbers or the exponents in the problem and the exponent in the answer. So the exponents here were 3 and 4. The exponent in the answer was 7. Exponents here were 2 and 3. Exponent in the answer was 5. Exponent here, understood to be a 1 and a 9, and the exponent in the answer was a 10. Well, when multiplying, which is what we were doing right there, we said we were only going to be multiplying monomials, or in other words, if we say we're finding the product, that's a fancy word that says we're multiplying things. So when we're multiplying expressions with the same base, what we do is we add the exponents. So you'll notice we did 3 plus 4 was 7, 2 plus 3 was 5, 1 plus 9 is 10. So here's the product rule for exponents. Product rule for exponents. So if I've got a base raised to a power times the same base raised to another power, we're going to write this same base, and what we're going to do is we're going to add these together. So this would be b to the m plus n. Now, it's not nearly as complicated as it might sound. It actually goes very quickly. So I'm going to slide down here and we're going to take a look at a couple of these problems. It says multiply the monomials and simplify the result. If the answer or the coefficient is more than 1500, leave it in exponential form. So this is a gigantic number. Maybe I'll pull up the calculator and show you how big that is. But here's the point. We have a number, a base, raised to a power. That same number, that same base, raised to a power. So what we're going to do here is we're going to say that that would be 7 to the 10 plus 19. So that's going to be 7 to the 29th. I'm going to circle that and we're all set to go. Now that's kind of like officially following this rule and stuff. You could quickly get to this answer by saying, look, if I've got 10 sevens here and I'm multiplying it by 19 sevens right here, I'm going to have 10 sevens from this, 19 sevens from this. So that means I'm going to have 29 of them all together. That would be totally fine. Okay? Now on this next one, I'm going to come over here and we're going to look at this box right here. It says when there are coefficients and variables. So we've got some coefficients and variables. We want to simplify the coefficients first, then simplify the variables and put them in alphabetical order. Alphabetical order. Okay, now we don't have any more than one variable on these guys right here. In fact, even D has only one variable. We're going to run into something that's a little bit more complicated down here, but we can still break this up into two parts. We kind of think of it as the coefficient here is -1 and the coefficient here is -3. Let's find that answer first. So we can think of it as -1 times -3 and then m to the 5th times m to the 1st. Now I've rewritten this so we can kind of see what's going on, and then we're going to multiply these together and we're going to get 3 here, and then we've got m to the 5th times m to the 1st. Well, this is 5 m's right here, this is 1 m right here, so this would be m to the 6th altogether. So if you wanted to, you could write this. You could write the 3 and then m to the 5 plus 1 and just kind of show all the work and thinking behind that, or you can skip right to there if you're able to do that. No problem either way. They go very quickly. I am going to speed this up over time so that we can get this right and do it as quickly as we possibly can. So I'm going to do one more where I rearrange these and then we'll just go forward from there. So on this one, I'm just going to move things around so I've got the numbers next to each other. So there's the -4 coefficient times the 6 coefficient, and then I've got x to the 5th and then times x to the 6th. Now we could just write these down, put dots in between them, or really nothing in between these except for the numbers, and everybody would know that that's implied multiplication, but I've gone ahead and written this. So we end up with this is -24, and then again I'm off to the side. I'm not going to write x to the 5 plus 6. I'm just going to say, look, if I have 5 x's here and 6 x's here, I add the exponents together, so altogether I've got 11 x's that are being multiplied together with that repeated multiplication. Okay, let's slide down here and take a look. This one we have a -9. There's only one coefficient here. Then we have a w to the 3rd, w to the 2nd, and again technically a w to the 1st. So the only coefficient we have here is -9. And then let's see how many w's we have. We've got 3 here, 2 here, and 1 here. So let's see how many we have. These together, 2 plus 1 is 3. 3 plus 3 would be 6. So altogether we have 6 w's that are multiplied together. So we're going to write that as a w to the 6th. So -9 w to the 6th, and that's it. All right, let's take a look at this one right here. This one has 3 different monomials, if you want to think of them that way. We're multiplying all of those together. And notice we've got some different coefficients and we've got some different variables here. So this is the first one where we might have to alphabetize these. So here's what we're going to do. We're going to take the numbers, and I'm going to write this off to the side so we can make sure we get this right. -2 times -5 times -5. The numbers, when we multiply those together, first of all, 3 negatives would make a negative, but let's just go ahead and check. Negative times negative is a +25, times -2 is -50. Okay, so we've got a -50 right there. That takes care of the coefficient. Now let's see what we've got here. We've got y to the 7th, x to the 2nd, y to the 3rd, and x to the 2nd. So I'm going to do this. Let's put those together. I've got an x squared and an x squared, and then I've got a y to the 7th and a y to the 3rd. So I've kind of rearranged these so that I can kind of visualize what's going on. So this is going to be, how many x's do we have altogether? We have 4 of them multiplied together. And how many y's do we have altogether? Well, if there's 7 here and 3 here, then we have 10 altogether. All right, and again, that's a very quick way of writing that repeated multiplication of y and x, and we're all set to go. So let's take a look at this last one. I'm going to do this pretty quickly without showing any work here. We're going to talk our way through it. So we've got the 6 times the negative 5. So that's going to be a negative 30. Then let's go through here and let's be smart about this. I took care of the 6 and the negative 5. If I've got a C, an A, and a B, I've got to do them alphabetically. So A, of course, is going to come first. So let's take a look at this one. I've got A to the 8th and A to the 2nd. So how many A's do we have? We have 8 here and 2 here. So this is going to be A to the 10th. So done with those guys. Let's take a look at the next variable. Let's take a look at B. If B is up next, we've got 3 here and 7 there. So altogether, that would be 10 B's that are multiplied together. So we'd have B to the 10th. We got that one taken care of. And then I've got a C here and C to the 9th right here. Well, remember, that's 1 C in a multiplication problem, 9 more. So that would be 10 C's multiplied together. So we have negative 30, A to the 10th, B to the 10th, C to the 10th. We're going to circle that and we are all set to go. Good luck on the assignment.